So I'm going to ask you some questions about chemistry. Feel free to tell me all your ideas. I'm not grading you, or this isn't about right or wrong. I just want to know your thought processes and all of that. So we're going to start with ice. Let me get that real quick. Okay, so I want you to hold this in your hand. You can hold it like this and stuff.
Oh, let it crack.
And I want you to tell me how would you explain what's going on to that ice cube right now?
Why it's on me?
Yeah, why
heat
is it-
transferring from my hand to the ice because heat goes to cold.
Yeah, that's a good way.
Let's go!
No.
Down. It's cold.
It's cold. So why are you feeling that cold onto your hand?
Something about losing heat.
Yeah, what's losing heat?
I don't know, probably
Yeah, you can put it
the oh my god.
baller.
Sorry, I don't know. The molecules in my hand are slowing down, or not in my hand, but on the surface are slowing down.
Okay.
Maybe.
Yeah, that's a good way to put it. What factors would you say are involved in that?
It has to do with transfer of heat. I don't think friction unless I'm moving it. Slowing. I don't know what. There's a process for that, but slowing down of molecules. When they hit each other faster, there's more heat.
Yeah, that's pretty accurate. Is it still the same substance? Would you say it's still water?
Mm-hmm.
Okay. So, what's the state of matter of that?
On on my hand or the solid ice.
Of both, what would you say?
Okay, well the ice is a solid, and the stuff, the water in my hand is a liquid.
Pretty good. Okay. What if your hands were the same, or as cold as the ice? Would the ice still melt in your hand?
Well, as cold meaning the same temperature, or just a little bit warmer?
Same temperature as the ice.
The air would probably melt it before my hand did anything.
Okay, so how would you explain that to someone who would, let's say a preschooler, let's say they're my hands are really cold, why is it still melting or something? Or if you're trying to explain to a 5-year-old, if your hand's the same temperature as the ice, why doesn't it melt? How would you explain that to someone?
Well, I'd just be it's like putting 2 ice cubes together, they're not gonna melt on each other. I can't really think of a deeper meaning.
That's a good way to put it, the 2 ice cubes. Okay, that seems pretty good. I'm gonna give you another ice cube, but in the meantime, while I'm getting that, I want you to warm up your hands.
Your affirmations are making me happy.
Get them nice and warm.
Oh, I have to do this shit again. Oh, I'm sorry, I have to do this again.
Oh yeah. I'll put it right here until you feel
Lots
like
of friction, yeah.
until your hands feel warm.
My hands are really warm.
Okay, and I want you to do that with the ice cube in it. Is there a difference between what you're doing now and what you experienced before?
So I'm not trying to sound problematic or nothing, but so I stopped rubbing my hands together in that moment between me stopping the friction and grabbing this, my hand temperature didn't drop much, but going this is making it melt faster.
Yeah, it's raining all over the carpet.
Oh, there's hair on it.
So what happened when you rubbed your hands together?
Well, my hands got warmer with friction.
That's pretty accurate. What's the state of matter of the ice cube now?
It's still solid here, but it's a liquid on my hands.
Very much a liquid on your hands.
And on our floor.
Are there any different factors involved this time around than the first time?
Friction.
Yeah, rubbing your hands together.
Yeah.
So, what did the particles look like on your hands when you were doing that?
Oh, they're probably like moving faster, cause like I'm moving them faster, and then as they heat up, they move faster, I guess.
Okay, so why would you say the heat on your hand, from you rubbing it, what's making it melt that faster? Are you saying?
Kinetic energy.
Oh.
Yeah, I'm using the big words now. I don't even know if that's the right big word. Something about kinetic energy. Yeah, it's like literally I've said the same thing over and over.
Yeah.
It's just heating up my hand.
Okay, so you keep saying heat. Can you describe that word to me? What that means to you, or what you think of that word, and what it implies?
I think of it just like molecules like speeding up fast enough to where they hit each other more frequently to create that like friction to make heat, I guess.
Okay, yeah.
That's about
So
it.
you're saying the faster they move, the
Well-
temperature goes up, or are you talking about?
I would say yeah.
Okay. All right. So now we're gonna remove this ice cube.
Let's see if I can make it.
No. Okay. So this container represents. There are nerds in here, right? The nerd candy. These are gonna represent the particles, right?
Got it.
Of that ice. Can you show me what particles would look like in an ice, like an ice cube? Okay, can you describe what's happening now?
Very slow movement because there's less particles, I would say. Wait, no, I'm sorry. They're more tightly packed, so they don't have as much room to move. So they're gonna be like squeezed together, not able to move a lot.
Okay, and in terms of what you described earlier as heat, how can you apply that to this state of matter?
What?
Okay, I'll just rephrase it. So just tell me what heat has to do with any of this. Like, why are
Just as the molecules are hitting each other, the friction creates heat. That's the only way I can like really describe it.
Okay, yeah, that makes sense. Can you show me the change from solid to liquid?
I mean, I guess it's just faster.
Yeah.
Like, not quite air. The air would be like... but, like... I'd say the liquid's about like this.
Okay, so yeah, that was my next question. It's a gas, which you pretty much did that pretty well.
Got ahead of myself.
Okay, so if you were teaching me about this process, how would you explain that to like a 5-year-old again?
Yeah, shoot. I would like to compare it to like cars, like traffic. But like not with the heat part, just how the molecules like collect with each other. Like in a solid, like the traffic's bad. Liquid, you're just going, and then like gas, you're probably like you and like 3 other people on the highway or something.
Oh, okay.
I don't know if kids understand traffic, but
It's something, a little example though. Okay. So you said gas was slowly moving, right?
no, I was going crazy for gas.
Oh,
crazy. Boy, yeah. Go crazy.
Get those nerds off.
Go
my
crazy, go
clusters.
stupid. Exactly.
Okay, so how would you get back into a liquid? Can you tell me what heat does, or the process?
What?
What is heat? Do you know
Oh.
what heat is, as in like a term?
Thermal energy, something
Okay,
like
so,
that.
yeah. Let's put you on track.
I know that it has to condense, so it probably gets cooler. Like the particles stop moving as fast, and like, cause that's how like rain happens, right? Like, or like it's humidity, like it gets really like dense, like the air does, and then it starts getting like water droppy.
Okay,
I honestly
yeah.
don't remember that process.
That's a good example. Can you walk me through? Yeah. Hey, come on, we're gonna make this 30 minutes. Can you walk me through the rain process? What you just described?
Oh,
Tell me
man.
more about that.
Okay. Liquid form in like a pond or something. And then it turns into gas as it evaporates because it's being like, the particles are heated up by the sun. Thermal energy. Got that one.
Ding!
Thermal energy heats up like the particles, I guess, and then they turn to gas. And then the higher up in the atmosphere, there's less pressure. It's cooler up there, less pressure, so they're gonna condense again, and then like into clouds, which are technically gas, unless I don't know, are they? I don't know. Don't ask me that. It's in a cloud, and then it'll turn back into a liquid. Well, it could be solid if it wants to come down as hail or something, but that's only if it gets high enough up there. But usually it's just gonna be rain. It'll like go from like, it'll cool down as a gas, turn back into liquid, and rain down. Then when it hits the ground again, it's gonna be liquid still.
Okay, so let's say this is the cloud. This is the cloud. What state is it in, if it's in the cloud state?
I would say it's still gas form until it gets heavy enough to drop as a liquid.
Okay,
I wouldn't know.
So it's like this, right?
Yeah, I'd say it's about like that.
Okay, and what makes it slow down?
Like cold. Losing thermal energy.
Okay, so energy's coming out of this cloud. Okay, so now it's nice and slow. It's raining. Is that
A little
what
bit
you're saying?
slower, yeah.
Okay.
Oh no, like that, yeah.
Yeah, so now it's in what phase?
That's liquid.
Okay, so these molecules are moving a lot more slower than previous gas, right?
Yeah.
Okay, what makes it go down into a solid?
You'd have to take even more thermal pressure or thermal energy, but that wouldn't happen unless you're way up in the atmosphere or like in really cold conditions.
Okay, so what if a kid was confused about this? What if they thought like in order for it to slow down, you had to take these particles out? What would you tell them?
You can't destroy matter. You'd be like,
Okay.
you can, I mean, I guess like, what do you mean take them out? Like as in just, they disappear or like you put them somewhere else?
Yeah, what if these just went somewhere else?
Oh, somewhere else?
Yeah.
I mean, it probably does through the process. Like some clouds, like some days, like when like there's clouds in the morning and then they disappear, it's because the sun evaporates some of the. I feel like it's because the sun evaporates some of it up.
Mhm.
So like, technically, they're not wrong. You can take some stuff out. I feel like, but like, I don't know how it. A kid would be really smart to ask, like, be like, so conceptually. I mean, I'd say no, don't take them, like, just fundamentally, like, no, you can't take them out, they're gonna go the same direction. Like, they're gonna go all the same, like, pattern.
Yeah, they're gonna stay in that system.
Yeah.
Okay. Yeah. So we took what did you say? Energy out.
Yeah.
And that's what makes it slower.
Yeah.
Okay.
I'd say you the transfer, not take out, more like transfer it.
Okay. So that's for it going from a gas to a liquid into a solid. We're taking that out. What happens when we go in the opposite direction? So now we're going from solid to a liquid and a gas. What does that energy go now?
That thermal energy, I feel like if you're melting an ice cube, like in a pan, and then it like evaporates obviously, but like, I feel like you're not getting rid of any, so it's not changing, like, it's changing states, not like actual composition, so you're not getting rid of molecules, you're just like expanding them, kind of, I guess.
Okay, so you're giving them more space, or you're expanding the size of these
No,
molecules?
molecules don't change size, unless
Okay.
they're like a different compound, right? So I would say that you're just giving them more space to move.
Okay, yeah. So you said heat or energy leaves when we're going from gas to liquid to solid. So how would you say that in terms of the other way? Opposite, kind
Like energy is taken in.
of. Yeah.
I guess like energy is just thermal energy is added.
Okay. Yeah. So it's not. Is it cold coming in?
Like if it was an ice cube, I'd be like, yeah, that's cold. But like cold is always like, or like cold, warm, hot, or like kind of, what's the word? I don't know what the word I'm thinking of is. It's very like objective or subjective.
Like
Some-
temperature. Just something.
yeah, like-
temperature.
I guess you could say like the molecules are like tighter, like have less space in the cold ice, and then the like lukewarm water they're less packed in, and then like as like it turns into like water vapor, it has lots of room to like freely move, I guess.
Okay, so you're saying like more space is hotter? More space has more
I'd say
energy?
more space means more energy and more like heat, I guess.
Okay. Cool. So energy and heat kind of go with each other, right?
Unless it's, well, you mean like adding energy or taking away?
Let's go through both. Look, we added energy to this box.
Okay, if you're adding energy, it's just generally like it's warmed up.
Okay, yeah. And then we take away energy.
I'd say you probably like put it in the freezer, like cooling it down.
Okay. Freezer, right? So if we, let's say we put, I'm gonna put it, I feel like it's my comfort. Actually, I might want this.
They're so good.
Okay, so, when we talk about this box right here, are we adding coldness? Are we taking away coldness?
You don't add coldness. I think you take away heat.
Okay, so cold isn't really a part of this, right?
No, I'd just say you're taking away heat.
Okay.
I think I learned that in like 5th grade or something. They're like, things don't get cold, you take heat away. I'm like, okay.
Yeah. That's actually like the premises of chemistry.
Oh. Should I be like,
She should
be a
teach
STEM
this.
major?
They're gonna recruit you now.
Y'all want me or what? Is this going to them?
Probably just my professor. I don't think she's gonna show up. I hope not.
The whole class.
Okay, those are all the questions I had for you. Is there anything you want to like talk about heat related? Anything you think of when you think of heat, or like a special fact?
I feel like you have much more to tell me than I could even tell you. I mean, I can make everything about me, but it's not going to be about heat. It's going to be about some other stuff. I don't even know.
What about how the way you feel heat in yourself? Is that the same as every other process?
I feel like some processes in your body that make heat have to do with like changing the actual composition of like the molecule. Like, you know how we like breathe in oxygen, breathe out carbon something, monoxide, dioxide. Forget. That's like changing. I don't know if that produces heat, but like I'm in my astronomy class and we learn things like like basic principles like that, where like you don't destroy the matter, it goes to another form, like whether it's heat or like there can be color, just stuff like that. I mean, that could be a body process that technically you could be like, it makes heat, but like you're not gonna feel it.
So, like you mentioned the sun earlier and how it heats things up. Does the sun do the same to you? Does it heat you up? Does it put energy somewhere?
Yeah, I'd say probably. The sun heats me up. And I start getting hot. I'd say maybe my. I feel like it's. I don't know the basic of it, but I feel like it's something along the lines of like. My body has to like make up for like all of the. Usually when I'm hot, I'm working out. So I'm like, it's all the like replenishing energy, and it's gonna make me like heat up because it's trying to like, it's going to like overdrive it. If I'm just outside and I'm hot, that's a great question that I cannot answer.
What happens though?
Maybe it just speeds up, like something. If it's like a skin, oh my god, my sunburn's bad. Like, I don't know, the molecules in your skin are like just going quicker because where else is the energy gonna go?
Yeah, so you're saying you're kind of like similar to the ice in the way the heat works on you? Okay. What about when you feel cold?
That's me losing heat. Like, if it's cold outside and I'm sitting out there without a blanket, like, all my heat's just gonna not all of it, but like my heat's gonna transfer out into the world to like attack the cold stuff.
That's on point. Have you ever seen like a football player like take off their helmet and them like steaming
Yeah.
How would you explain that?
I'd say it's such a rapid, like, or it's such a, not rapid, it's such a, like, drastic difference between the outside temperature and your inside. And that steam is just the water. Or, like, I think it's just the sweat that's, like, collected. And I know things with salt in them, I think, don't they evaporate faster?
Salt?
Don't things with, like, salt or, like, sodium, like, evaporate faster?
I don't know that for a fact.
I
could look it up.
Yeah, I was like, I feel like I heard that somewhere. Or, like, I don't know. I feel like when you see the steam coming off their heads, that's the... What is that?
Actually, salt would make it evaporate
Slower?
because it's heavier.
Okay. That makes sense. I've seen the steam. I know it has something to do with, like... I don't know, actually. I just know that it's, like, only when it's really cold outside and the football players are really hot.
Okay, so, like, simplistically, how would you explain that? Of what we, like, everything I just got out of you earlier, or, like, in this interview, how would you explain it in those terms that we just talked about?
Oh, man. Hot to cold, but... I wonder if it's the... I wonder if that steam is, like... I wonder if it's evaporated from the water, like, I wouldn't know. Or, like... I also don't know why it would evaporate, because it's cold outside. That is so weird. I really couldn't explain it to... If someone asked me, I'd be like, I don't know. It's
Okay,
cold
so
outside.
you're saying, like, oh, it's really cold outside, too, right? It's really cold. It's not a hot day. Normally, it's a cold, like, snowy day when this happens, when they take off their helmet and, like, steam comes out. And then, let's say, like, the internal temperature for, like, them inside from playing so much, what are they doing with that energy? How would you explain the energy in that process?
Well, I guess their body heat's transferring out into the, like, air, and maybe that's, like, oh, wait. Isn't steam? That's, like, water vapor, so it's that technically. I was like, wait a minute. So it's going from gas to, like, almost liquid state when it's steaming. So I guess it's, like, their hot, like, body interacting with the cold air to take it down a level of, like, I guess you would say down a level, but to take it, like, to a different state.
Change the state of matter of all of that.
True that.
That was pretty good. I'd say you know a lot more about chemistry than most people.
Yeah, it's because I'm a business major. Did you
Plug.
assume I wouldn't know anything? Did you assume I wouldn't know anything just because I'm into marketing?
She's a marketing major. I thought I would get her.
I know, honestly, I thought I'd get got to.
No, it was a pretty simple.
Yeah, it's like stuff we kind of learned in elementary school.
Yeah.
But I understand why you would forget it. Like,
especially you did good with the heat stuff.
Yeah,
Like, I thought I was gonna get you with the getting it colder.
Are you gonna interview someone else?
I'll probably interview my dad. I'll probably stop the snow.